So here we have our rotational kinematics equations, and we're going to talk about the step process in order to determine when you should use which. So the first thing you should always do before you start that is you should convert your units first. So if you have revolutions, you need to multiply it by 2 pi. If you have RPM, you need to convert to rad per second. And if you have rev per second, you need to multiply by 2 pi. Because all of these units are your time, your t, your alpha angular acceleration, your omega initial, and your omega final, all and your theta, they all require these units. So here are our equations. Let's add one more here. We also have, okay, so and we have change in theta, WF plus initial over 2 times T. So after you've got your units, the second thing you do is you need to find what's missing. And you want to avoid the equation that has the stuff with this. So let's talk about this first equation. WF squared, omega final squared is equal to omega initial squared plus 2 times the angular acceleration times the angular displacement. This is the one that has no time. If you don't know what the time is, then you use this equation. Now, what about if you have this equation? This is also, yes, F. So this is when you have these omega initial, omega final, and also time. This is allows you to solve for acceleration. Now, if you need angular displacement, you use this equation. Omega t plus that. So now what about if you have both angular velocities and you also have time? Then you use this. Now, if it starts from rest, let's talk about some cases. Like if you have starts from rest, immediately what you can do is you have omega initial is equal to 0. So then you have omega f squared is equal to 2 times alpha times change in theta. Now, if you have something that says comes to a stop or rest or comes to rest, then you set WF equal to 0. Now, for conversion, your velocity is equal to the r times the angular, or sorry, times the rotational velocity. Acceleration is equal to r times the angular acceleration. X is equal to r times theta. So remember, overall, remember to convert revolutions to radians. Also, don't use degrees, use radians. Also, choose an equation that includes a missing variable and drops negative signs for deceleration. Drop negative signs for deceleration, because you know the direction it's heading in. You can just write that. So ultimately, you just need to know these 4 golden equations, which will be on your AP Physics 1 formula sheet. But also just remember that you have to strategically choose which equation you choose to solve with.